Now we're going to be getting into what I consider the most important part of the class, which is the use of SQL, or the structured query language. SQL is a standard used by nearly all relational database systems. The class session on DDL and DML notwithstanding, we're going to focus on a very small subset of SQL and primarily concern ourselves with queries. Having fluency with SQL queries and its use will provide tremendous value throughout your career and allow you to extract data from databases without having to translate your requests through another person. There are a number of different statements that are used in SQL, but we're going to focus on queries, and queries always start with select. Select acts effectively the same way that a question mark does at the end of a sentence. In fact, you should think of queries as being strictly structured questions. You need to be precise in what you're asking because the computer doesn't have the ability to read between the lines and figure out what you want, and we probably wouldn't want it to do that anyway. Every query is going to return a relation as a response. Sometimes the result of a query might be a single number, but that number is going to be returned as a one-by-one table or relation. Remember that the basic currency of relational databases is a relation of tables, so it makes sense that this is how it would respond to you. Each query takes a basic form of select columns from tables where some condition is true. And we can complicate that more as we head on from there. So let's take these one by one. So just a note is that all examples from here on out are going to be using the Zaggy database, which can be accessed on HeidiSQL or through the virtual lab if you'd like to follow along on your own. You don't need to do this to understand the lesson though. So in order to figure out queries, we're going to start with the from line, which inconveniently doesn't actually come first. Here, we're specifying which tables from within the database we want to pull information from. In this case, we're going to use a table called product. Now, the clause after select specifies the columns that I want to be returned in the relation. I can always use the wildcard character, or star, if I just want everything. Or if I only want some specific columns, I can list those individually and return those. So in general, you're going to start every query by selecting which columns you want, or select columns, and from which tables you want it, or from table. Now note that without the where clause, it's going to return the entire table to me, and that's fine. Maybe that's what I want. But maybe I'll want a subset of this, and this is where the where keyword comes in. So before we talk about the where statement, let's take a little diversion to talk about Boolean logic. A Boolean statement is one that can be evaluated to either true or false, and with no in between. One common Boolean statement compares two numbers with an operator in between them. So let's say we're comparing 1 and 1. We have a few ways to do this. First is whether 1 is equal to 1. Obviously, our vast intellects can deduce that these are the same number, and as such, this is true. We might want to see if 1 is less than 1, and in this case, that's false. If we wanted to include statements that are less than or equal to, we'd have to use the less than or equal to operator. We can also test for something that's not equal, which is to say 1 is not equal to 1, which would come back false. Numeric values can be tested for being greater than or less than, but we can test if two values of any type are equal to each other. For example, we can test the contents of two strings or even the contents of two Boolean statements for equality. Now, while we can test for equality between two Boolean statements, we also have a further set of tools that allow us to combine statements. The two most important of these are and or. Like the operators we discussed on the last slide, these tests have two sides, but both sides have to be Boolean statements, so either true or false directly, or more often, two statements that can be evaluated to true or false. The AND operator will return true if and only if, or IFF, both sides of the AND operator are true. If one or both sides is false, the AND operator will return false. These can be chained together. In other words, in many cases, we'll only want to return true if four tests return true. Let's say W and X and Y and Z will accomplish that. The OR operator, on the other hand, will return true if and only if at least one side is true. In other words, X or Y will return false only if both X and Y are false. There's a subset of this called exclusive OR, or XOR, that's important in circuit design, but you can safely ignore this for SQL. It's worth pointing out that generally speaking, AND makes the resulting set more restrictive or smaller, while OR will make the list less restrictive or larger. There's also a negating operator, which is not. Think of not like a negative sign. Normally we'd use this when we want to test for a situation where X is true and Y is false, for example. X and not Y would return true in these cases. So why do we care about true and false statements? This is the grammar we're going to need in order to filter what gets returned to us using where. In slide 3, we return the product ID and product name columns from the product table. Let's say I'm only interested in products that cost less than $100 though. If we append where product price is less than 100 to do that, we'll get to a table that has fewer rows. Let's discuss what SQL is doing to arrive at that. The first two lines of the query that we used to find the columns that we wanted in the tables that we wanted those columns from. Before the database got to the where line, it pulled every single row that met those criteria. Now the database is going to go row by row on these and run a Boolean test. So we've asked only for rows where the product price is less than $100. So row by row, the database tests this. For product 1x1, is the product price less than 100? In this case, it's false. 100 is not less than 100. For 2x2, is 70 less than 100? This is true, and so on. Once it goes through this list, it returns the resulting relation as the answer. Then, in other cases, we need to be more specific. Let's say I need all footwear, or category FW, items that have a price greater than $50. Or in other words, I only want to see items where two conditions are both true. This looks like a job for a friend and. So we'll say that we want rows where both condition A, price is greater than 50, and condition B, category FW, are true. The AND itself is evaluated last and is accordingly going to be what tells the database what to include. So it runs this behind the scenes and returns the two rows where this is true. Finally, we might want to return cases where one of a list of conditions are true. Let's say we're interested in products that have a price greater than 100 or is footwear. Even in describing it, I said or, so maybe we should use that. Again, the database does what it does behind the scenes and then it returns results.